Bismillahirrahmanirrahim. In this video, we will study about the random variables. Before this, you have used the word variable, simple variable, in frequency distribution. What is the difference between variable and random variables? This is most important thing. So when we use variable and when we use random variable, first I will explain what is the difference between the variable and random variable. You know that you have used the word variable in first lecture, first video, types of the variable. You know that basically we have two types of variables, two types of data: qualitative data or quantitative data, qualitative variable, quantitative variable, and two subtypes of the quantitative variable: discrete variable and continuous variable. We have done in frequency distribution or frequency distribution table. So what is the difference? This is the most important thing. You know that in frequency distribution we distribute the frequencies, values, actual value. For example, suppose if you collect the data of the height, weight, temperature, etc. In general, we use the word variable. Height, weight, temperature are continuous variable. Number of students, number of patients are discrete variable. In general, we use the word X, alphabet X. X is a variable in general. But this is the random variable. So what is the difference? This is most important thing. What is the difference between variable and random variables? You have solved three different questions in frequency distribution table, three different types of data or variable in frequency distribution table. We have done this. So variable, what is a variable? You have used in frequency distribution. Variable represent all the values, all the collected data, actual data, raw data. And what is the random variable? Random variable represent the possible results of the variable. So first I will explain the definition. This is the definition of the random variable. Then again I will repeat the difference between the variable and random variable. The definition is: a random variable is a variable that contain or obtain or takes different values, contain or obtain different values as a result. This is the most important word, of the outcomes. Not only outcome, result of the outcome of a random experiment. A random variable may be either discrete or continuous, same as the variable. If a random variable contains a finite number of values, it is called discrete random variable. If a random variable contains any value within a given range or an infinite number of points on a line, it is called continuous random variable, same as the discrete and continuous variable. So what is the difference between variable and random variable? Variable represent all the data. Suppose if you have 100 observations, So variable represent all the 100 observations, and then we convert in frequency distribution, distribute the observations or values in the form of group if the number of observations are large, for example 40, 35, 45, 50 and so on. But when the number of observations are small, directly we calculate or interpret the data. But what is a random variable? Random variable used in probability distributions. Probability distribution may be the discrete or continuous, but according to your syllabus we will study only discrete probability distribution. Variable, only variable, not random variable, variable used in frequency distribution, and random variable used in probability distribution. It's the use of the variable. When we use the word variable, when we use the word random variable, variable used in frequency distribution, random variable in probability distribution. So how you will decide either the given variable is variable or random variable? This is the important thing. So random variable is a result of the outcome if we represent the result of the outcome according to the values of the result and probability. So first we will find the probability, then we can construct the probability distribution or probability distribution table. So the presentation of the probability distribution is in the form of values of x and probabilities, corresponding probabilities. So what is the probability distribution? All the possible values, all the results values that a discrete random variable can take on along with the associated probabilities, along with the associated probabilities. In frequency distribution we represent the value of x with the corresponding frequencies, but in this along with the associated probabilities is called discrete probability distribution, or the set of ordered pairs. Ordered pair means value of x and probability of x. Probability of x is also represented by f of x, where f of x is the probability of x is equal to x. So when we represent the value of x with frequency, the table is called frequency distribution table. If we represent the value of x, result of the variable, with corresponding probabilities, the table is called probability distribution table. This is the difference between the use of the variable and random variable and presentation of the variable and random variable. If you present the variable with frequencies, it is called frequency distribution table. If you present the random variable with probability distribution, it is called probability distribution table. So set of ordered pairs x f of x is called the probability function or probability distribution of discrete random variable x, where f of x is equal to probability of x is equal to x. So this is an example. You have solved this example 2 or 3 times in different headings. In definition of the sample space and event, you have used this example, and in probabilities you have used this example. Now again we will use same example. You can understand easily what is the difference between the variable and random variable. You know that variable represent all the values, random variable represent the result of the outcomes, possible results of the outcomes. So if we throw a coin 3 times, total number of outcomes are 8. Okay, if x is the number of head occur, you have used same statement in last 2 lecture or videos. If x is the number of head occur, so if you represent the value of variable head occur In the form of variable, possible values of x may be 0 head in this, in these 3 1 head, in these 3 2 heads, in this one outcome only 3 head. So possible values are 0, 1, 2, 3. This is the result of the outcomes. The number of head may be 0, maybe 1, maybe 2, maybe 3. Either the outcome occur one time, number of head occur one time, or 3 times or one time. We write only values, result of the value. So this variable x is called random variable if we represent the value of x 0, 1, 2, 3 with the corresponding probabilities. You have already calculated this probability in previous video. This is the probability. Out of 8, 1 time 0 head occur, 3 times 1 head occur, 3 times 2 heads occur, 1 time 3 heads occur. So this variable is called random variable. Now same example, if you throw a coin 3 times, outcomes are 8. If you represent like this, x is equal to 0, 0 1 time, 0 head 1 time, 1 head 3 times, 1, 2, 3, represent each outcome or member of the element by separate 1, 1, 1. 0 means 0 head, 1 means 1 head, 1 means 1 head. There are 3 times 1 head occur. Same as 2 head occur 3 times, write 2 3 times. 3 head 1 time. So if variable x represent all the values individually, not result of the outcome 0, 1, 2, 3, this is the actual values, then the variable is called, x is simply called variable in frequency distribution. X is simply variable in frequency distribution. If you represent in the form of frequency 0, 1, 2, 3, in frequency column 1, 3, 3, 1. This is the relative frequency. If you represent the values of x with frequencies in the form of group, is called frequency table or frequency distribution table, because in frequency distribution table we distribute the frequencies. In probability distribution table we distribute the probabilities. Sum of the probability is always equal to 1. If you add all these values, will be equal to 8 upon 8 equal to 1. So this is the difference between the variable and random variable. So we will use the word random variable in probability distribution table and different formula of the probability distribution. Same as the frequency distribution table, we will also find the mean, standard deviation and mode, etc. according to your syllabus. Okay, the method is different. You know that in frequency distribution we use the value of x and corresponding frequencies in mean and mode and standard deviation. Okay, same as in probability distribution, for mean we will use the value of x with corresponding probabilities, not frequency. So this is our next topic. Find the mean of the data, mean of the probability distribution, mean, median, standard deviation or mode, etc. So topic is called mathematical expectation. Okay, because the mean represents the expected value, central value, is also called or expected value of a random variable x, or mean of random variable x, or mean of its distribution. Its distribution means distribution of the random variable x according to the probabilities. So what is the formula? The sum of the product of each value of the random variable with that value's probability of occurrence is called mathematical expectation of random variable x, denoted by E in bracket x. In frequency distribution, the definition of mean is the sum of the product of midpoint or value with frequencies of occurrence. In this we use the probability of occurrence. In frequency distribution we use the word frequencies. This is called the mathematical expectation in this topic. In probability distribution and in frequency distribution is called mean, or random variable x denoted by Ex. This is also called the mean of the Ex is also called the mean of the probability distribution. So for mean of the probability distribution we use this notation and this formula. So the expected value of a random variable tells where the center mass, center mass of the probability function is located. For discrete random variable x with range x1 to xn and probability, corresponding probability x is equal to xi is equal to f of xi, you can use f of xi, or probability of x is equal to xi. For formula or function we use this. For condition of the probability we use this notation. Both are same. The expectation of x is defined as Ex defined as first value of x multiplied by corresponding frequency plus second value of x multiplied by frequency, and so on up to last value. Same as here, this value multiplied by this plus sign, this value multiplied by this sign, value multiplied by this plus this value multiplied by this. Okay, so we can combine these values in the form of formula. Xi, x1 2 3 4 5 6 7 8 9 means xi. Fx1 fx2, instead of long statement you can use fxi. I vary from 1 to n, so you can write summation sign I equal to 1 to n, same as the formula of the mean and standard deviation. Is also called mean of probability distribution, Ex. Now some laws of expectation. If a and b are constant, then expected value of constant a into x plus b is equal to Ex mean value multiplied by constant plus constant, both will be same, equal. If this value Ex, expected value of x is here, so this will be x, probability will be same. Either if this value is x square, x cube, ax plus b, we will multiply by the corresponding probability. So if this value is x, we write here x. If this value instead of x is ax plus b, we will write here ax plus b. We will prove this numerically. This is the first law. The expected value of the sum or difference of two random variables is equal to the sum or difference of the expected value of the individual random variable. For two random variable, sum or difference of two random variable, mean value will be equal to individual sum or difference of mean value. And same as product, if you multiply both variable and then calculate mean value, or if you calculate separate mean value of both variable then multiply, result will be same or equal. But the mean of the two variables is not included in your syllabus. In frequency distribution and probability distribution is also called bivariate distribution. So bivariate distribution is not included for mean, median, mode, standard deviation and probability. So second and third law is not included in your syllabus. And number fourth law is find the variance and standard deviation. And variance and standard deviation both are same. If you take the square root of the variance, you will obtain the standard deviation. And formula of the variance, sigma square is the notation for variance. E equal to Ex square minus Ex whole square. This Ex is the same as the formula of the mean. Ex is equal to xi, fxi you have written in this same formula. And what will be the x square? Ex square. If this term is x square, we will write here x square. First we will calculate the x square, then multiply by corresponding probabilities. You will obtain Ex square, then substitute here Ex square, minus sign, value of Ex here, then whole square. This is the Ex square, this is the Ex whole square, both are different. You will obtain the variance sigma square. If you take square root, will be standard deviation. Variance of x square root will be sigma. So two laws are included in your syllabus. Number second and third is not include of the bivariate variable. Okay. Now example, the probability distribution table is given already after calculating the probability. If suppose the probabilities are not given, first we will calculate the probability same as the question number 1, 2, 3, 4, 5 and 3 question I gave you in homework. Okay. So first we will find the probability. A random variable x, this is already given, a random variable x, because the probability of the random variable is also given. Has the probability function or probability distribution. The possible values of x is given 0, 1, 2, 3. Probabilities are given 0.1, 0.3, 0.4, 0.2. If you calculate sum of this probability will be equal to 1 always. Show that expected value of 2x plus 5 is equal to 2ex plus 5. This is the first law. Eax plus b is equal to aex plus b. Also find the mean, mode and standard deviation for the probability function or probability distribution. So first we will calculate Ex. We will take right hand side, then left hand side. So right hand side, first we will calculate Ex. The formula of the Ex. First value of x is 0 into probability 0.1 plus second value 1 multiplied by corresponding probability, third value multiplied by probability, fourth value 3 multiplied by probability. This is the given data. 0 multiplied by this, 1 multiplied by this, 2 multiplied by this, 3 multiplied by this. Simplify this, you will obtain Ex 1.7. Okay, and then substitute this Ex in right hand side. Here multiply by 2 plus 5. Put here 1.7, this value. Multiply by 2 plus 5, 8.4. This is the right hand side. And left hand side is E2x plus 5. Substitute instead of x here 2x plus 5 and then substitute the value of x 1 by 1 with corresponding probability. Same as this. So substitute the value of x 0, then multiply by 2 plus 5, right in bracket, into first probability 0.1 plus sign. Put here x is equal to 1. Multiply with corresponding probabilities. Put here 2. Multiply by probability. Then put here 3. Multiply by probability. And simplify this term. 0 plus 5. 5 into 0.1 will be 0.5. This multiply by this. This multiply by this. You will obtain same as this. So you have proved this. E2x plus 5 is equal to 2ex plus 5, first law. Okay. Now find the mean. You know that Ex is called mean, and you have already find this Ex in proof. Right hand side is equal to left hand side. This only Ex is called mean. So mean is equal to Ex. Ex is the 1.7, so mean is the 1.7. And what is the mode? You know that mode is the most frequent or repeated value. Mode is the most frequent or repeated value, or highest frequency indicate the model class. If the frequency is high, relative frequency or probability will be high or large. In this data, in this table, probability distribution table, you can observe the highest probability is 0.4 and corresponding value of the highest probability is 2. So 2 is the mode, the value of x 2 occur 40%. This is the 10%, 30%, 40%, 20%, or you can say out of 10, 4, 2, 3, 1. Highest frequency indicate highest probability, corresponding value is called mode. So most frequent value gives highest probability, and highest probability is 0.4, so mode is 2. Without any formula, you can calculate the mode direct from the highest probability. Now find standard deviation. For standard deviation, first we will find x square. You have already find the value of ex 1.7. For ex square we will use this formula. Ex square is equal to x square f of x1. First calculate square of the x is the 0, this is the probability, plus second value of x1 square into probability square of 2 into corresponding probability square of 3 into corresponding probability. The square is only for this value of x, not for probability. So simplify this, you will obtain 3.7 ex square. Now substitute in formula ex square 3.7 ex, you have already calculated this 1.7 whole square. Simplify this, 2.89, subtract from this 0.81, this is the variance. The standard deviation will be square root of this 0.81 will be 0.9. So this is the standard deviation of the given probability distribution table. In this question, probabilities are given. If probabilities are unknown, first you will find the probability, then you can find mean. So in next question, you have solved this question in simple probability. This question is the same as the previous homework, and question number 5. 5 novel book, 3 book of poem and 1 dictionary and so on. But in this we will apply one more step. We will find the mean value of the variable x. If x is the number of defective sets purchased by the hotel, find the mean of x. A shipment of 7 television sets contain 2 defectives. Defectives are 2 out of 7. There are 7 television, which is 7 minus 2, non-defective will be 5. So a shipment of 7 television sets contain 2 defectives. A hotel make a random purchase of 3 of the sets. Size of the selection purchase is the 3. If x is the number of defective sets, so first we will write all the values, all the possible values result of x, then we will find the probability, and then you can find the mean of random variable x, find the mean of x. So defective 2, non-defective 5, total is 7, size of selection 3, all possible selection will be out of 7, 3, n combination n, 7 combination 3 will be equal to 35. The possible result, possible outcome we will write in denominator, and x is the number of defective sets. This is the probability, so we will convert the table into probability distribution table. So x is the number of defective sets. Possible values of x will be 0, 1, 2. If you have 2 defective sets, if hotel purchase 3 sets, the maximum defective set may be 2 or maybe 1 or 0. If hotel purchase out of 7 3 sets, out of 3 may be 0 defective, 3 non-defective, 1 defective, 2 non-defective, 2 defectives, 1 non-defective. So we will find the probability of defective set. Probability of x is equal to 0 defective, 1 defective, 2 defectives. And denominator will be 35, all possible outcomes. There are 2 categories, defective and non-defective. Same as the question number 5, you have 3 categories, novel book, book of poem and 1 dictionary. In this there are 2 categories, defective and non-defective. If hotel purchase 3 sets and out of 3 0 defective, property of x equal to 0 means 0 defective and 3 is non-defective. Simplify this, 2 combination 0 1, 5 combination 3 will be 10, multiply this 10 upon 35. So the probability of 0 defective sets will be 10 upon 35. Same as find the probability of 1 defective sets. Out of 2, 1 defective. If 1 defective, 2 will be non-defective from 5. Simplify this using formula of the combination, you will obtain 2 into 10 upon 35, 20 upon 35. If 2 are defectives. Total defectives are 2. Out of 2, 2 defectives, 1 will be non-defective from 5. Simplify this, 1 into 5 divided by 35, 5 upon 35. So if you represent the value of x with corresponding probabilities, the table is called probability distribution table, and then you will find the mean of x. So in this question, 2 topics are included. Find the probabilities of different conditions, 0 defective, maybe 1 defective, maybe 2 defective, maybe less than 1 defective, maybe more than 1 defective, etc. And then find the mean of x, means EX, mathematical expectation or expected value of x. So if you represent in the form of table, 0 with 10 upon 35, 1 with 20 upon 35, 2 with 5 upon 35, the table is called probability distribution table. And then calculate mean EX, 0 multiplied by 10 upon 35, x into probability, plus sign, summation sign means plus sign, 1 into 20 upon 35, 2 into 5 upon 35, simplify this, 30 upon 35 equal to 0.86, 0.86. This is the mean of x, mean of random variable x, or mean of defective sets. Okay. Now for homework, solve the question number 2 and 6, page number 150. Question number 2 and question number 6, page number 150. In question number 2, the same as this question, question number 2, formula is given, substitute the value of x, you will obtain the fx or probability of x. Okay, and in question number 6, values of x and f of x, probability of x, both are given, same as the previous example. This example, 2 values of x and 2 probabilities are given, but there are, in this question, question number 6, you have 2 categories, loss and profit. For loss, we will subtract the value in negative sign, and for profit, the value will be positive. Value of x, not probability. Probability is always positive. So try to solve this question, question number 2 and 6. Allah Hafiz. Next time we will start probability, discrete probability distributions. Allah Hafiz.